The Earth was once again thrown into chaos by a large object falling from space. This time it's much worse than an asteroid. It's you. You accidentally flew too close to the sun in your new experimental aircraft, and now you're hurtling toward our nearest star at over 200,000 miles per hour. The atmosphere is hot enough to burn solid rock to dust. But as you get closer and closer to the sun, can anything remain intact? Will you be completely incinerated before reaching the surface, or will you make it all the way to the center of the sun? Let's find out. Our sun is what astronomers call a G-type main sequence star, also known as a yellow dwarf. That's right. Stars have types, which is determined by their size, temperature, and brightness. The largest stars are called red giants, and the smallest are white dwarfs. Our sun falls in the middle of the stellar size chart. It is about average in terms of its luminosity, meaning how bright it shines. However, the sun is far from average when it comes to temperature. In fact, it's pretty dang hot. If you're anywhere near the sun, say within 10 million miles, you will feel its heat. At that distance, the sun's radiation could heat you to 63 degrees Fahrenheit, or 17.2 Celsius. If you were foolish enough to venture any closer, however, things would quickly become very uncomfortable for you. At 93 million miles away, which is the Earth's distance from the sun, you'd be met with temperatures around 110 degrees Fahrenheit, or 43.3 degrees Celsius, hot enough to broil a nice piece of steak in just 2.5 minutes. At this point, if you haven't already, you probably should turn around because things are about to get seriously toasty. As you cross the orbit of Mercury, the closest planet to the sun, you'll feel the heat rise to 177 degrees Fahrenheit, or 80.5 degrees Celsius. The further you go, the faster the temperature climbs. And before long you'll be met with temperatures hotter than the surface of Venus, which averages 867 degrees Fahrenheit or 464 degrees Celsius. But it gets even hotter as you approach the sun. At 750,000 miles away, the temperature reaches nearly 2,300 degrees Fahrenheit or 1587.8 degrees Celsius. And at 250,000 miles away, you'll find yourself in temperatures as high as 5,400 degrees Fahrenheit or 2926.1 degrees Celsius. At this point, if you're not vaporized yet, you're probably dead either from being burnt alive or from the intense pressure crushing you like a grape. Now, some of you may be wondering what the temperature actually is at the sun's surface. Astronomers can't agree on a number, so there is no definitive answer. Estimates vary from around 9,000 degrees Fahrenheit or 4,182.2 degrees Celsius to a scorching 27,000 degrees Fahrenheit or 14,926.7 degrees Celsius. That's a pretty big range, but one thing is for sure. If you manage to survive the 200,000-mile fall towards the sun, you won't survive much longer, even if you made it past the sun's corona, which is the outermost layer of its atmosphere. You wouldn't last long in the sun's chromosphere. This is the layer of the sun's atmosphere where most of its light is emitted. Temperatures in the chromosphere range from around 2,000 degrees Fahrenheit or 1093.3 degrees Celsius at its outer edge to a sizzling 40,000 degrees Fahrenheit or 21,500 degrees Celsius at its inner edge where it meets the photosphere. As you pass through the chromosphere, you'll see the sun in a whole new way. The photosphere is the lowest layer of the sun's atmosphere. It's what gives the sun its characteristic fuzzy appearance. The temperature in the photosphere ranges from around 3,000 degrees Fahrenheit or 1,650 degrees Celsius at its top to around 10,000 degrees Fahrenheit or 5,500 degrees Celsius at its bottom. But that's nothing compared to the sun's radiative zone. This is the layer of the sun where energy is transported outward by radiation. This is the layer of the sun where energy is transported outward by convection. Temperatures in the convective zone range from around 70,000 degrees Fahrenheit or 38 to 800 degrees Celsius at its inner edge to around 100,000 degrees Fahrenheit or 55,000 degrees Celsius at its outer edge, where it meets the sun's core. But the sun's core is like nothing you've ever seen. Here temperatures can reach 27 million degrees Fahrenheit, or 15 million degrees Celsius. At this point, you're completely surrounded by plasma, which is a superheated state of matter that's found in stars like the Sun. The intense heat and pressure in the Sun's core causes hydrogen atoms to fuse together to form helium, which releases tremendous amounts of energy. This is what powers the Sun and gives us light and heat. As you continue to fall towards the Sun's core, the pressure and temperature will continue to increase until you reach the Sun's very center. Here the temperature can reach a staggering 157 million degrees Fahrenheit or 87 million degrees Celsius. Even if you manage to survive the fall from 200,000 miles away, you won't survive much longer. In fact, you won't survive the rest of the fall at all. At this point, you're completely engulfed by the Sun's core, and you're completely crushed by the immense pressure. The pressure at the Sun's core is about 250 billion times the Earth's atmospheric pressure. That's equivalent to having 250 billion Earth atmospheres stacked on top of you. You'd be utterly crushed into a pancake. So let this be a lesson to all of you daredevils out there. If you're ever flying near the Sun, make sure you keep a safe distance. Otherwise, you just might end up as solar fuel. But if you want to know what would happen if you fell into a different kind of star, then check out this video next. Let us say you accidentally flew too close to a blue star in your new experimental aircraft, and now you're hurtling toward the nearest blue giant at over 200,000 miles per hour. Blue stars are the hottest and most massive stars in the universe. They are also the rarest type of star. Our Sun will never be a blue star because it doesn't have the mass required to make it happen. Stars like our Sun will exhaust all of their hydrogen fuel in about 10 billion years. When this happens, they will collapse under their own gravity and become white dwarfs. White dwarfs are the smallest, coolest, and most dense stars in the universe. To make a white dwarf, you need something about 8 times the mass of Jupiter. That's pretty dense. Blue stars, on the other hand, are massive. They are between 5 and 30 times the mass of our Sun. These stars shine bright because they burn their fuel very quickly. In fact, a blue star can burn through its entire supply of hydrogen in less than 1 million years. That's 10 times faster than our Sun. When a blue star runs out of hydrogen, it collapses and forms a neutron star. Neutron stars are incredibly dense. In fact, a single teaspoon of neutron star material weighs about 1 billion pounds. That's heavier than 10 African elephants. So if you fell into a blue star, you would be utterly crushed by the immense gravity. In fact, you wouldn't even make it to the surface of the star. You would be crushed to death long before you got close. Or maybe you thought you could outrun the star by falling straight through its core. After all, a blue star's core is about 30,000 miles wide. That's bigger than the Sun's core, which is only about 20,000 miles wide. So you would have plenty of room to fall, right? Wrong. A blue star's core is so dense that it's like trying to run through a wall. You would be met with such strong resistance that you would be brought to a screeching halt almost immediately. And then you would be crushed by the immense gravity of the star. You might be wondering, why doesn't the intense heat of the blue star melt me before I hit the core? That's a great question. But the answer is no. A blue star's core is so dense that the intense heat is actually greater on the inside of the star than on the surface. So if you fell into a blue star, you would first be met with temperatures as high as 10,000 degrees Fahrenheit or 5,500 degrees Celsius. You would be burnt to ashes in a matter of seconds. But that's not even the worst part. The worst part is that after you're burnt to ashes, you would still be crushed by the immense gravity of the star. You would be crushed into a pancake so thin that you would be indistinguishable from a sheet of paper. And then you would be utterly destroyed as you passed through the star's core. So if you're anywhere near a blue star, be careful. It might look beautiful, but it's deadly. Well, that's all for now. If you enjoyed this video, please leave a like and subscribe for more content. We've got lots of videos about space and science and technology coming up, and we hope you'll stick around to check them out. Thanks for watching. Death inside a K-type star. The silent but deadly inferno. Imagine you're an astronaut on a mission to explore the vast expanse of our universe. As you venture further into the cosmos, you stumble upon a K-type star, a relatively small and cool star with a faint reddish glow. But as you get closer, you realize that something is amiss. Despite its unassuming appearance, this star holds a terrifying secret, a silent, invisible inferno that can easily end your life. Welcome to our channel, where we bring you the most spectacular and terrifying events from the depths of space. Today, we'll take you on a journey to the heart of a K-type star, where death awaits in the most unexpected form. So buckle up and get ready for an adventure that will leave you speechless. K-type stars are relatively small and cool stars that make up around 4% of the stars in the Milky Way. They have a surface temperature between 3,700 and 5,200 Kelvin, which gives them a distinctive reddish glow. These stars are much less massive than our Sun and have a diameter that ranges from 0.6 to 1.2 times the size of our Sun. Despite their small size, they have a significant impact on the universe and play a crucial role in the life cycle of stars. The process begins when a giant gas cloud collapses under the force of gravity. As the cloud collapses, it forms a hot, dense core that eventually becomes a protostar. As the protostar continues to gather mass, its core heats up until nuclear fusion begins. This is when hydrogen atoms are converted into helium, releasing a tremendous amount of energy. This energy creates an outward pressure that balances the inward pull of gravity, and a star is born. Throughout the star's life, it will continue to fuse hydrogen into helium in its core. As the star ages, its core will gradually build up a helium-rich core, while the outer layers of the star become enriched with heavier elements such as carbon and oxygen. When the star runs out of hydrogen fuel, it will collapse and its core will heat up to extreme temperatures. This heat will trigger the fusion of helium into heavier elements such as carbon, neon, and oxygen. Depending on the star's mass, this can result in a supernova explosion or the formation of a white dwarf. One of the most interesting features of K-type stars is their strong magnetic fields. These magnetic fields are created by the rapid rotation of the star and are much stronger than the Earth's magnetic field. The magnetic fields are highly variable and can change over time scales of days to years. They can also be highly dynamic, with sudden and significant changes in strength and structure. The magnetic fields of K-type stars have a significant impact on their behavior. They can affect the star's atmosphere, creating bright spots and flares. They can also interact with the material in the star's accretion disk, producing X-rays and other forms of high-energy radiation. Understanding the magnetic fields of K-type stars is an active area of research in astrophysics, and scientists are working to unravel their complexity and influence on stellar behavior. In addition to their magnetic fields, K-type stars also exhibit a phenomenon known as stellar rotation. Like all stars, K-type stars rotate on their axes, and this rotation can be quite rapid. The rotation rate of a star can affect its shape, stability, and overall behavior. Some K-type stars rotate so rapidly that they are nearly as wide at the equator as they are tall, which can cause them to wobble and become unstable. This instability can lead to dramatic eruptions of material from the star's surface, creating spectacular displays of stellar activity. Another fascinating aspect of K-type stars is their chromospheres. The chromosphere is the middle layer of a star's atmosphere, and it is characterized by a gradual increase in temperature with height. In the case of K-type stars, the chromosphere can extend several thousand kilometers above the star's surface. The temperature in the chromosphere can reach several thousand degrees Kelvin. K-type stars have particularly large and active chromospheres, which are sites of intense stellar activity. In these regions, the magnetic fields and rotation of the star create turbulent conditions that lead to the formation of sunspots, flares, and other dynamic features. Studying the chromospheres of K-type stars provides valuable insights into the stellar atmospheres and the processes that drive their behavior. But now let's turn to the darker side of these celestial bodies. K-type stars may seem like a relatively safe place to visit, but don't be fooled. They have a secret that can easily end your life. Underneath their calm exterior, these stars have a sinister side that can pose a deadly threat to anyone who gets too close. One of the most dangerous aspects of K-type stars is their stellar winds. Stellar winds are streams of charged particles that flow outward from a star's atmosphere. K-type stars have strong stellar winds that can reach speeds of hundreds of kilometers per second. These winds carry with them a significant amount of energy and can easily damage or destroy spacecraft. If your ship is not properly shielded, these winds can fry your electronics, disable your life support systems, and leave you stranded in the vast emptiness of space with no way to contact Earth. But the danger doesn't end there. K-type stars are often surrounded by disks of debris and dust that can be harmful to human health. This debris is created by the star as stellar wind and can include heavy elements that are toxic to humans. If you were to inhale these elements, they could quickly poison you, making it impossible for you to survive. And then there's the radiation. K-type stars emit a significant amount of radiation, which can be deadly to humans. Radiation can damage DNA and other vital molecules, leading to radiation sickness and even cancer. If you were exposed to the radiation emitted by a K-type star, you would likely succumb to radiation poisoning, making your journey to the heart of a K-type star a one-way trip. But perhaps the most terrifying aspect of K-type stars is their complete silence. Unlike our Sun, K-type stars do not emit sound waves that can travel through the vacuum of space. This means that if you were near a K-type star, you would not be able to hear anything. You would be completely alone in the darkness, unable to communicate with Earth or any other source of help. This isolation can drive a person insane, making the experience even more terrifying. It's hard to believe that something so small and seemingly insignificant could be so dangerous. But K-type stars are a reminder that the universe is full of surprises, and it's important to be prepared for anything. As an astronaut, it's your job to explore the unknown and venture where no human has gone before. But when faced with the deadly dangers of a K-type star, it's important to know when to turn back. Don't let your curiosity get the better of you, and risk your life for a few moments of glory. Sometimes it's better to live to fight another day than to die trying to conquer the unknown. If you find yourself near a K-type star, don't panic. Take a deep breath and assess the situation. If your ship is damaged, try to repair it as quickly as possible. If your life support system is compromised, ration your air and water carefully. And if you're exposed to radiation, put on your spacesuit immediately to protect yourself. It's also important to remember that you're not alone in the universe. There may be other explorers out there who have encountered K-type stars and survived. Reach out to them and see if they can offer any advice or assistance. Remember, knowledge is power, and sharing information can help keep you safe in the vast expanse of space. And finally, never lose hope. Even in the darkest hours, there is always a glimmer of hope that you can make it through this ordeal alive. Keep your spirits up and focus on the task at hand. With a positive attitude and a clear mind, you can overcome any obstacle that comes your way. So if you ever find yourself exploring the depths of space and stumble upon a K-type star, be sure to take these precautions to ensure your survival. Remember, death inside a K-type star is a silent but deadly inferno that can easily end your life. Don't let it happen to you. Thanks for watching. If you enjoyed this video, please hit the like button and subscribe for more amazing content. And if you want to learn more about K-type stars or other fascinating topics in astrophysics, check out the links in the description below. Who knows, You might just discover a new passion or gain some valuable knowledge. Until next time, keep looking up and stay curious. You know that saying, curiosity killed the cat? Well, if this rule had one exception, it would be me. Because when I see something interesting in space, my curiosity always gets the better of me and I just have to find out more. Like these pictures, for example. They were taken by NASA's Chandra X-ray Observatory and show something we don't see every day, two stars colliding in space. It might seem like a terrifying sight, but chances are, any star collisions you witness will never hurt you because there are no stars anywhere near our solar system that could collide with Earth. That is, unless you consider red dwarfs. And yes, they're technically stars. It's just a weird group of stars that are smaller than our Sun. And so far we found around 3249 of them in our Milky Way galaxy. But if you think all that means our planet is safe from danger, well, think again. In today's video we are going to answer the question, can falling into a red dwarf destroy Earth? So make sure to watch until the end. Red dwarfs make up about 75% of the Milky Way's stellar population, but their small size and relatively low luminosity makes them difficult to spot. While red dwarfs typically have less mass than other stars, they have similar lifespans as bigger stars thanks to their slow rate of nuclear fusion. But being able to live for a really long time doesn't mean you will be alone for most of it. One study found that red dwarfs can host habitable zones within a surprisingly wide range of distances from their stars. This means that despite their small size, red dwarfs can have planets that could potentially support life. But this also means that those same planets could be destroyed by their star. To understand why, let's first look at what a red dwarf actually is. These stars are about half the size of our Sun, which means their gravity is much stronger. If you were to step onto the surface of a red dwarf, you'd weigh almost twice as much as you do on Earth. But that's not even the worst part because its atmosphere is full of hydrogen and helium, and due to the star's high gravity, these gases would form a thick, hot, shimmering wall around its equator. If Earth were to get too close to such a wall and go through it, it would instantly face temperatures of around 9,000 degrees Celsius, hot enough to melt rock and vaporize water. And unfortunately for us, this happens to be right in the middle of the star's habitable zone. So how exactly does a red dwarf destroy a planet? Let's take a closer look at the process of a star forming. Stars are born from massive clouds of gas and dust that collapse under their own gravity. As the cloud collapses, the material starts to heat up and spin faster and faster. Eventually, the core becomes so dense and hot that nuclear fusion occurs, and a new star is born. Red dwarfs are no different. However, they are much less massive than other stars, and therefore do not burn through their fuel as quickly. This means that they have very long lifespans, up to 10 times longer than our Sun. The low mass of red dwarfs also means that they have a weak stellar wind, which is a stream of charged particles flowing outwards from the star. This weak wind allows matter to accumulate closer to the star than would be possible with more massive stars. As a result, the habitable zone of a red dwarf is located very close to the star. This means that any planets in this zone would receive enough heat from the star to support liquid water on their surface. However, it also means that these planets are very close to a powerful star with a strong gravitational pull. Red dwarfs have very strong gravitational pulls because of their small size and high density. This means that if a planet were to get too close to a red dwarf, it could be pulled apart by tidal forces. To make things worse, red dwarfs are also known to be flare stars, meaning that they frequently produce intense bursts of energy called flares. These flares can easily strip away the atmosphere of a planet, leaving it exposed to the harsh radiation of space. What's more, red dwarfs often have giant planets orbiting very close to them. These planets can easily be ejected from their orbit and sent on a collision course with nearby planets or even Earth. On top of that, red dwarfs tend to have more companion stars, meaning that Earth may not only have to deal with one powerful star, but several at once. All these factors combined make the possibility of a red dwarf destroying Earth a very real threat. It may seem like a far-fetched scenario, but it's important to remember that over 80% of stars in the Milky Way are red dwarfs, and many of them are likely to have planets in their habitable zone. With over 100 billion potentially habitable worlds out there, the chances of us finding life elsewhere in the universe are incredibly high. And while we may never encounter an alien civilization that wants to do us harm, there is always the risk of encountering a star that wants to harm us. Luckily for us, no red dwarfs are close enough to Earth to pose a threat. The closest red dwarf to us is called Proxima Centauri, and it is more than 4 light-years away. However, with thousands of red dwarfs in our galactic neighborhood, the chances of a rogue one entering our solar system are not zero. If you ask me, it's only a matter of time before something comes along and destroys us all. But jokes aside, astronomers are actively searching for signs of life on planets around red dwarfs. And if we ever do find evidence of life, it will be important to understand the risks involved in visiting such planets. The danger posed by red dwarfs is just one of the many challenges that we will face as we explore the galaxy. But it is a challenge that we must be prepared for if we want to ensure the survival of our species. Now let's go back to our initial question. How would falling into a red dwarf affect Earth? To answer this question, we need to understand what would happen to our planet during the collision. When Earth entered the atmosphere of the red dwarf, it would experience intense heat and pressure. The atmosphere of a red dwarf is mainly composed of hydrogen and helium, which would cause the Earth's atmosphere to rapidly expand and heat up. The intense heat would melt the Earth's crust and mantle, turning our planet into a giant ball of hot liquid. At the same time, the pressure from the red dwarf's atmosphere would cause the Earth's oceans to boil and evaporate, adding to the expanding atmosphere. As the Earth continued to fall towards the center of the red dwarf, it would be met with even higher temperatures and pressures. The core of a red dwarf is estimated to be around 10,000 times hotter than the Sun, which means that Earth would be completely vaporized before reaching the star's core. At this point, our planet would cease to exist, and its remnants would be added to the red dwarf's atmosphere and interior. So how long would this whole process take? It depends on several factors such as the mass of the red dwarf and the speed at which Earth is falling towards it. However, it's safe to say that the entire process would happen very quickly, possibly within minutes or even seconds. So the bottom line is, don't go anywhere near a red dwarf unless you want to turn into hot soup. But what if we could control the process? What if we could somehow use the power of a red dwarf to benefit humanity? For example, scientists have proposed the idea of using a red dwarf's gravity to accelerate a spacecraft. By placing a spacecraft near a red dwarf, we could use the star's gravitational pull to accelerate it to high speeds without having to expend any fuel. This could potentially allow us to travel to other parts of the galaxy much faster than we currently can. Another potential application of red dwarf technology is in the field of energy production. Red dwarfs emit a constant stream of charged particles that could be harnessed to generate electricity. This could provide a clean and sustainable source of energy for human settlements on planets or in space. However, these are just theoretical ideas, and we are currently limited by our technology and understanding of physics. The truth is that red dwarfs pose a much greater threat to humanity than they do opportunity, and it's important to understand the risks involved in dealing with such powerful stars. If you enjoyed this video, then check out our other videos where we explore the most extreme environments in the universe. From supermassive black holes to exploding stars, there's always something new and exciting to learn about the universe and the amazing discoveries that scientists are making all the time. Don't forget to subscribe so you never miss an upload. Until next time, keep looking up. Stars are some of the most beautiful and awe-inspiring objects in the universe. They come in a wide variety of colors, shapes, and sizes, and they have fascinated humans for millennia. But what would happen if you entered a star? Let's take a journey into the heart of a star and find out. If you entered an F-type star, you would be met with temperatures ranging from 6,000 to 8,000 Kelvin, which is hot enough to melt rock and metal. The light from an F-type star is predominantly yellow-green in color due to its high surface temperature. The intense heat and pressure at the core of these stars cause hydrogen to fuse into helium, releasing tremendous amounts of energy in the process. This energy is what makes stars shine, and it's also what makes them so dangerous. As you venture deeper into the star, you would be met with even higher temperatures and pressures. At some point, the temperature would become so high that even the atoms would be stripped of their electrons, creating a plasma. You would find yourself surrounded by a sea of positively charged nuclei and free electrons. The radiation pressure from the star's core would be so intense that it would push you outward at incredible speeds. Despite the danger, many scientists dream of one day visiting a star like our Sun. With current technology, it would take over 4,000 years to reach even the closest star system. But with new advancements in propulsion systems, it may one day be possible. For now, we can only use our imaginations to explore what it would be like to enter a star. Some stars are much larger than others and offer more opportunities for exploration. If you were to enter a red giant, you could travel for weeks or even months before reaching the core. At the core of the red giant, you would find temperatures of around 10 million Kelvin. That's 1,000 times hotter than the surface of the star. The immense heat and pressure at this depth would make it impossible for you to survive, but it would be a sight to behold nonetheless. As you journeyed further into the star, you might encounter pockets of helium and other elements that have been fused together due to the star's immense gravity. The star's atmosphere would become thinner and thinner until you reached a point where there was almost no matter left. You would be met with a blinding white light as you approached the star's core. The light would be so bright that it would be impossible to look directly at it. Even the toughest materials would be vaporized by the intense heat, and you would be reduced to a cloud of gas. But what if you were able to survive the journey to the star's core? What would you actually see? Stars are powered by nuclear fusion, the process of combining light nuclei to form heavier ones. This fusion process occurs in the star's core, where the intense heat and pressure create the perfect conditions for it to take place. If you were to enter the core, you would see hydrogen atoms being fused together to form helium. This fusion process releases tremendous amounts of energy in the form of light and heat, which is what makes stars shine. You would also see the different layers of the star's core. Stars are not homogeneous, and they have different layers with different properties. The core is the innermost layer, and it's the region where nuclear fusion takes place. The radiative zone surrounds the core, and it's the region where energy is transported outward by radiation. The convective zone is the outermost layer of the star's core, and it's the region where energy is transported outward by convection. If you were able to survive the journey to the center of a massive star like our Sun, what would you find? The answer might surprise you. Our Sun is a G-type main sequence star, also known as a yellow dwarf. It has a mass of about 2 million kilograms and a radius of 700,000 kilometers. The Sun is about halfway through its life cycle, and it has about 5 billion years left to live. At the center of the Sun, you would find temperatures of about 15 million degrees Celsius and pressures of about 250 gigapascals. These conditions are extremely hostile, and no human could survive for more than a few seconds in such an environment. The core of the Sun is a dense ball of plasma, containing mostly hydrogen and helium. The hydrogen atoms are so tightly packed together that they are compressed into a state of plasma, meaning that they have lost their electrons and become ionized. This plasma is in a state of constant motion with particles colliding with each other at high speeds. As you move further away from the core, the temperature and pressure would decrease until you reach the radiative zone. In this zone, energy is transported outward by radiation. The particles are still very close together, but not as tightly packed as in the core. As you moved further out, the temperature and pressure would continue to decrease until you reached the convective zone. In this zone, energy is transported outward by convection. The particles are much further apart, and there is enough space for them to move around more freely. If you were somehow able to survive the journey to the center of the sun, what would you actually see? The answer is not much. Due to the extreme density and pressure at the center of the sun, light cannot travel through it. This means that the center of the sun is completely black, and you would not be able to see anything if you were there. The only way to see anything would be to bring your own light source, such as a flashlight. However, the intense heat and pressure would likely destroy your flashlight before you even got close to the sun's core. The closest star to Earth is Proxima Centauri, which is located about 4.2 light-years away. With current technology, it would take over 4,000 years to reach even the closest star system. But if we were to develop new methods of space travel, such as nuclear fusion engines, then it may one day be possible to visit stars like Proxima Centauri. If we were to travel to Proxima Centauri, we would need to take several precautions. First, we would need to protect our spacecraft from the intense radiation that is emitted by the star. Stars emit a large amount of radiation, and this radiation can damage the spacecraft's electronics and also pose a risk to human health. Therefore, we would need to develop new materials that are resistant to radiation in order to protect our spacecraft. Second, we would need to develop new propulsion systems that are capable of reaching the speeds necessary to travel to nearby stars. With current technology, it would take over 4,000 years to reach even the closest star system. However, if we were to develop new methods of space travel, such as nuclear fusion engines, then it may one day be possible to visit stars like Proxima Centauri. Third, we would need to ensure that our spacecraft is capable of sustaining a crew of astronauts for the duration of the journey. The journey to Proxima Centauri would take many years, and the astronauts on board would need to be provided with food, water, and oxygen throughout the journey. We would also need to ensure that the spacecraft is capable of maintaining a comfortable temperature and atmosphere for the astronauts. Finally, we would need to develop new technologies for communicating with Earth while traveling to a nearby star. The distance between Earth and Proxima Centauri is so great that it would take many years for messages to travel between the two planets. Therefore, we would need to develop new methods of communication that can transmit messages faster than the speed of light. In conclusion, entering a star like an F-type star would be a deadly dance in blinding heat. The intense temperatures and pressures would destroy any spacecraft and kill any humans who ventured too close. However, it's a fascinating thought experiment that allows us to explore the amazing power of stars. With advancements in technology, it may one day be possible to visit stars like our Sun and explore the mysteries of the universe. However, it would require significant advancements in many areas of science and technology, and we are still many years away from being able to do so. Thank you for watching, and I hope you learned something new. If you have any questions or comments, please leave them below. And don't forget to subscribe for more amazing videos about space and the universe. Until next time, keep looking up. If you fell into a massive star, you would be met with a sight unlike any other. A mind-blowing mixture of hydrogen, helium, and other elements. The star's surface could reach temperatures of up to 30,000 kelvins, hot enough to vaporize almost everything in a matter of seconds. Even if you somehow managed to survive this, you wouldn't for long, because falling into the core of a massive star would be even worse. But what if we make it even more extreme? What if you fell into an O-type star? It's a rare type of massive star that has a surface temperature higher than any other known star. The hottest stars in the universe can reach temperatures of over 60,000 kelvins, and at those high temperatures, you wouldn't last very long at all. In this video, we will discuss what would happen if you were to fall into one of these incredibly hot stars. First off, let's take a look at what an O-type star actually is. As mentioned earlier, it's a rare type of massive star with a surface temperature higher than any other known star. They are extremely bright and massive, with 10 times the mass of our Sun and a radius over 20 times larger than our own. These stars are short-lived, burning through their fuel very quickly and often go supernova, exploding with incredible force and releasing huge amounts of energy. When you picture an O-type star, think of the hottest parts of a barbecue grill, where pieces of wood or charcoal can reach temperatures of up to 1,000 degrees Celsius. But multiply that by 60,000, and you get an O-type star's surface temperature. Now imagine falling into this inferno. You would be met with a sight unlike any other, a swirling vortex of superheated plasma. The star's surface could reach temperatures of up to 30,000 kelvins, hot enough to vaporize almost everything in a matter of seconds. Even if you somehow managed to survive this, you wouldn't for long, because falling into the core of a massive star would be even worse. To give you an idea of how hot the core of a massive star can get, let's look at our Sun. At its core, the Sun reaches temperatures of about 15 million kelvins. That's already unimaginably hot, but it's nothing compared to the core of a massive star. In the core of a massive star, temperatures can reach up to 100 million kelvins. That's 67 times hotter than the core of our Sun. Now imagine being inside a massive star as it goes supernova. The star's core collapses in on itself, causing a massive explosion that blasts material out into space at incredible speeds. If you were inside the star, you would be met with a shockwave that would literally blow your body apart. The explosion would be so powerful that it would blast you out of the star and into space, leaving nothing but atoms. So what would happen to your body during this process? When you fell into the O-type star, the intense heat would vaporize your body in a matter of seconds. Your body would be turned into a hot plasma, a superheated state of matter where electrons are stripped away from atoms. At these high temperatures, no human body could survive. The intense pressure would also cause your body to be compressed. As you descended deeper into the star, the pressure would increase dramatically. Eventually, your body would be crushed into a pancake-like shape. But what if you were somehow still alive through all of this? The radiation would quickly kill you. O-type stars emit huge amounts of radiation, which is why they are so bright. This radiation is deadly to humans, and you would be met with a lethal dose of radiation as soon as you entered the star. The radiation would damage your DNA and cause your cells to die. Even if you managed to survive the initial blast, the radiation would eventually catch up to you and kill you. But what if you were somehow still alive? The extreme conditions inside a massive star would quickly end your life. The high-energy environment would cause your body to break down, and the intense heat and pressure would cause your organs to fail. Even if you managed to survive all of this, the lack of oxygen would eventually kill you. Inside a massive star, there is no oxygen, so you would suffocate and die. But what if you were somehow still alive? The intense gravity would crush you. The gravity inside a massive star is incredibly strong. It would pull on your body and cause it to be stretched out like taffy. Eventually, the gravity would be too much for your body to handle, and it would collapse. But what if you were somehow still alive? The extreme temperatures and conditions inside a massive star would quickly end your life. Your body would be met with unimaginable heat and pressure, causing it to break down at a molecular level. The star's atmosphere would also be incredibly turbulent, with powerful winds and storms that would tear your body apart. But what if you were somehow still alive? The radiation inside a massive star is incredibly harmful to humans. It would damage your DNA and cause your cells to die. The intense radiation would also cause your body to glow. You would become a human torch, burning brightly before being consumed by the star. But what if you were somehow still alive? The intense pressure inside a massive star would crush your body. The pressure would be thousands of times greater than the Earth's atmosphere, causing your body to be compressed into a small space. Your bones would be shattered, and your muscles would be turned into a thick soup. But what if you were somehow still alive? The lack of oxygen inside a massive star would suffocate you. The absence of oxygen would cause your body to shut down, and your cells would die. But what if you were somehow still alive? The insane gravity inside a massive star would pull you apart. The gravity would be hundreds of times greater than Earth's gravity, causing your body to be stretched and torn apart. But what if you were somehow still alive? The extreme temperatures and conditions inside a massive star would quickly end your life. Your body would be met with unimaginable heat and pressure, causing it to break down at a molecular level. The star's atmosphere would also be incredibly turbulent, with powerful winds and storms that would tear your body apart. But what if you were somehow still alive? The radiation inside a massive star is incredibly harmful to humans. It would damage your DNA and cause your cells to die. The intense radiation would also cause your body to glow. You would become a human torch, burning brightly before being consumed by the star. But what if you were somehow still alive? The intense pressure inside a massive star would crush your body. The pressure would be thousands of times greater than the Earth's atmosphere, causing your body to be compressed into a small space. Your bones would be shattered, and your muscles would be turned into a thick soup. But what if you fell into an O-type star instead? All of the above scenarios would still occur, but the intensity would be much greater. An O-type star is the hottest type of star in the universe. Its surface temperature can reach up to 60,000 kelvins. To put that into perspective, the surface temperature of our Sun is about 6,000 kelvins. Therefore, the temperature of an O-type star is 10 times hotter than our Sun. You wouldn't even have time to react before your body was vaporized by the intense heat. If you managed to survive the initial impact, the radiation would quickly kill you. O-type stars emit huge amounts of radiation, which is why they are so bright. This radiation is deadly to humans, and you would be met with a lethal dose as soon as you entered the star. But what if you were somehow still alive after all this? The intense pressure inside the O-type star would crush your body. The pressure would be millions of times greater than the Earth's atmosphere, causing your body to be compressed into a small space. Your bones would be shattered, and your muscles would be turned into a thick soup. It's safe to say that falling into an O-type star would be one of the worst things that could happen to a person. It would be an experience full of unimaginable horrors, from the intense heat and pressure to the powerful radiation and gravity. But what if it didn't have to be the end of the story? What if you could somehow survive this ordeal? Well, unfortunately, the answer is no. Falling into an O-type star would be a death sentence. Your body would be met with an unimaginable hell, and there would be no way out. So if you ever find yourself near an O-type star, just remember, don't fall in. It could be the worst mistake you ever make. If you enjoyed this video, be sure to leave us a thumbs up and subscribe for more amazing science videos. We've got plenty more where that came from. Thanks for watching. If you fell into an A-type star, your body would be ripped apart by the immense gravity before being burned to death in its intense radiation. In this video, we'll explore what happens when you fall into an A-type star, starting with how you'd experience falling into one of these massive stars from a relatively safe distance away. As you approach the surface, the temperature would quickly increase, causing your skin to burn and your body to feel like it was on fire. You would then be met with an intense gravitational pull that would stretch your body like spaghetti. Finally, you would be burned to a crisp as you cross the boundary into the star's hot plasma. But before we get to this gruesome fate, let's start at the beginning. Imagine standing on a faraway planet, looking up at an A-type star filling the night sky. This star is huge, radiating an incredible amount of heat and light. Its gravity is also incredibly strong, so you know you shouldn't go anywhere near it. But for some reason, perhaps because you're a scientist or an intrepid explorer, you decide to get as close as you can. As you begin your journey towards the star, you'd notice the intense heat radiating off its surface. The further you got, the hotter it would become until your skin started burning. At first it would just be a light sizzle like when water hits a hot stove, but soon you'd be met with searing pain as your flesh cooked on the outside while the inside of your body started to boil. All the water in your body would evaporate, leaving nothing but dry, charred skin. If somehow you managed to survive this initial barrage of heat, you wouldn't for long. The closer you got to the star, the stronger its gravity would become. And as you approached the surface, this force would begin to rip your body apart. It would feel like someone had taken your arms and legs and stretched them in opposite directions, pulling you into a pretzel shape. Your bones would snap, and your muscles would tear as your body was stretched beyond its breaking point. But even if you were somehow still alive after this initial gravitational assault, you wouldn't remain that way for long. As you finally crossed the boundary into the star, you would be met with an even more intense amount of heat. The temperature inside an A-type star is around 8,000 kelvins, which is about 7,700 degrees Celsius, or 13,400 degrees Fahrenheit. At this temperature, your body would be vaporized instantly, meaning that if you fell into an A-type star, your body would literally turn into gas. Any remaining solid matter would be blasted away from the star's surface by its powerful stellar winds, while your atoms would be scattered throughout the star's hot plasma. So if you ever find yourself near an A-type star, make sure you don't get too close. Now, let's continue our exploration of what would happen if you fell into an A-type star. Once you've been vaporized, your atoms will be scattered throughout the star's hot plasma. Here they'll be met with an incredible amount of energy, as the nuclear fusion reactions occurring in the star's core will cause the plasma to vibrate at incredible speeds. Your atoms will be jostled around by the plasma particles, gaining energy and eventually becoming ionized. Ionization is the process of removing an electron from an atom. When your atoms are jostled around by the plasma particles, they will gain enough energy to lose an electron, turning them into ions. These ions will then be blasted away from the star's surface by its powerful stellar winds. If you were somehow still alive at this point, which is highly unlikely, your body would be completely disintegrated. You wouldn't even be able to recognize your own atoms, as they would be completely scrambled and mixed in with the plasma. Even if you managed to survive all this, you wouldn't for long. The intense radiation inside an A-type star is deadly. The amount of radiation you'd be exposed to as you fell into the star would be thousands of times greater than the amount that kills a person on Earth. In just a few seconds, you'd be bombarded by high-energy photons, which would rip apart any remaining molecules in your body, turning you into a pile of radioactive ash. At this point, you'd be completely dead, and there'd be no trace of you left. So if you ever find yourself near an A-type star, make sure you don't fall in. And if you did, well, just be prepared for a horrible death. Now let's talk about the surface of an A-type star. As you approach the surface of an A-type star, you'll notice that it doesn't look like anything you've seen before. Instead of being a solid object, the surface of the star is a swirling mass of plasma. This is because stars are giant balls of burning gas, and their surfaces are really just the outermost layer of their atmospheres. The surface of an A-type star is extremely hot, reaching temperatures of around 8,000 Kelvin. This is around 7,700 degrees Celsius, or 13,400 degrees Fahrenheit. The heat from the surface of the star radiates outward, giving it an intense glow. This glow is what makes stars visible to us from Earth. If you were to touch the surface of an A-type star, your body would be instantly vaporized. The intense heat would break down the bonds between the molecules in your body, turning you into a gas. In fact, you wouldn't even be able to survive for a fraction of a second on the surface of an A-type star. Stars are also incredibly massive. The smallest A-type stars are around 2.1 times the mass of our Sun, while the largest can be as much as 5.9 times the mass of our Sun. This means that the gravity on the surface of an A-type star is much stronger than the gravity on Earth. If you were to fall onto the surface of an A-type star, you would be utterly crushed by the immense pressure. The gravity would be so strong that it would literally squeeze the life out of you. You'd be utterly crushed into a pancake. The surface of an A-type star is also very turbulent. The plasma is constantly churning and boiling, creating enormous waves of heat and light. These waves crash into each other and can reach heights of over 100 kilometers. If you were on the surface of an A-type star, you would be tossed around like a rag doll in a washing machine. It's important to note that the surface of an A-type star is not solid. Stars are made up of gas and plasma, and their surfaces are really just the outermost layer of their atmospheres. This means that if you were to step onto the surface of an A-type star, you would sink into it up to your knees, waist, or even deeper. The hotter the star, the thinner its atmosphere, and the less dense its surface. So while you wouldn't be able to stand on the surface of an A-type star without sinking into it, you'd have a bit more luck standing on the surface of a hotter star. Despite the immense heat, radiation, and pressure on the surface of an A-type star, there's still one more thing that would kill you if you fell into one of these massive stars. Stars are giant balls of burning gas, and as such they emit a constant stream of charged particles called solar wind. The solar wind is made up of electrons, protons, and other small atomic nuclei which stream away from the star at high speeds. If you were to fall into an A-type star, you would be met with a constant barrage of these charged particles. The solar wind is so strong that it can literally blow you away from the star's surface. In fact, if you were to stand on the surface of an A-type star, the solar wind would be strong enough to knock you off your feet and send you tumbling through the air like a leaf in a hurricane. The solar wind is also dangerous because it carries with it a lot of energy. The charged particles in the wind collide with each other and with objects in space, transferring their energy in the process. This can cause the object to heat up and even explode. For example, if you were to fall into an A-type star and get caught up in the solar wind, you could be heated up to thousands of degrees in just a matter of seconds. This would literally roast you alive. So if you ever find yourself near an A-type star, make sure you stay away from the surface. If you thought the burning, stretching, and disintegration weren't bad enough, you now know that you'd be met with an intense blast of hot gas if you somehow managed to survive all this. A-type stars are among the most dangerous objects in the universe. They are massive, hot, and incredibly luminous, emitting tremendous amounts of radiation that can literally burn you to death. Even if you manage to survive the initial impact with the star's surface, you wouldn't last long in the intense environment. You'd be utterly crushed by the star's gravity, then torn apart by its powerful stellar winds before being roasted alive by the star's intense radiation. So if you ever find yourself near an A-type star, make sure you keep your distance. Thanks for watching. In our solar system, there is no such thing as a real-life hell, or at least not one that we know of. But if we were to travel to other stars, then we might find something very close to it, especially if they are of the B-type. Imagine falling into one of these stars. What would happen to your body? Would you be incinerated instantly? Would your body explode? Let's get to the bottom of this. First, let's take a look at what a B-type star actually is. They are massive, hot, bright, and very rare. These stars are about 2 to 4 times larger than our Sun and have surface temperatures of between 10,000 to 30,000 kelvins. That is more than twice the temperature of our Sun. Our Sun will never be a B-type star because it isn't massive enough. The smallest B-type stars are already bigger than our Sun. And for comparison, the biggest B-type stars are absolute giants, measuring over 16 billion kilometers in diameter. That is just crazy. This means that even if you manage to dodge the searing heat, you wouldn't escape a B-type star without getting crushed by its immense gravity. But what exactly happens when you fall into a burning plasma ball of unimaginable heat? Well, the answer depends on how fast you were going when you fell. In any case, your body would quickly begin to burn up in the atmosphere of the star. As you got closer and closer to the core, you would eventually reach temperatures hotter than the surface of the star itself. The material that makes up the star's atmosphere, known as photospheric plasma, would become so dense that it would start crushing your body. You would be squeezed from all sides by the intense gravitational force of the star. Then your body would be completely crushed and torn apart by powerful plasma flows. If you weren't moving that fast, then you would find yourself burnt alive as the star's atmosphere would engulf you entirely. Either way, you don't stand much of a chance. Now let's imagine that somehow you managed to survive falling into a B-type star. You could breathe normally, and everything appeared to be fine except for the fact that you're inside a burning star and everything around you is extremely hot. Even if you were made entirely out of metal and were the strongest human on the planet, you would still die very soon after entering a B-type star. It would take less than a second for your brain to overheat and stop functioning. Also, the intense pressure would cause your heart to explode, pumping blood everywhere. The heat would melt your bones and organs, while the strong magnetic fields generated by the star's rotation would tear your muscles and skin to shreds. And all of this would occur while you're still conscious and aware of what's happening. Can you imagine anything more terrifying than that? Now let's imagine that for some impossible reason, you managed to survive falling into a B-type star. You had superhuman strength and a special suit that protected you from heat and radiation. Let's call this suit the Doomsday Suit Mark II. And you're wearing it, you feel fine despite being inside a giant ball of burning plasma. However, soon you notice that the star's gravity begins to pull your suit further and further down towards the core. You know that if you reach the stellar core, then you won't survive. Its temperature is about 9 million degrees Celsius, which is more than 8 times hotter than the surface of the star. Your only option is to flee from the star's core. But unfortunately, the atmosphere is so dense that it's like trying to swim through thick honey. The deeper you go, the thicker the plasma becomes. It's so sticky that it clings onto your suit and doesn't allow you to move freely. Finally, you get stuck and can no longer move. Your only option is to turn around and head back towards the surface of the star. When you turned around, you realized that the magnetic fields had an even stronger effect on your suit than you thought. They began to pull you in a spiral motion. Soon you were spinning so fast that you couldn't see anything anymore. Your suit was now torn apart by the magnetic fields. The atmospheric pressure outside of the suit was thousands of times greater than the pressure inside. This caused your blood to boil and explode. Your insides were slung out of the torn suit and thrown around inside the star. At this point, you were no longer a person. You were just pieces of flesh and bone being tossed around inside a giant star like trash. Meanwhile, the magnetic fields continued to spin you around until every part of your body was torn to shreds. All of your cells burst and died instantly. Now, with no one inside to control it, the Doomsday Suit begins to malfunction. First, its cooling system shuts down and it begins to overheat. The suit was no longer protecting you from the star's extreme temperatures. It begins to melt, and your remains are slung out of it. Now you are just a pile of melted metal. You float up through the star's atmosphere and pass by countless hydrogen balloons that are falling to the core to be burned. Eventually, you approach the surface of the star, where you are met with unbearable temperatures. You are vaporized, and your atoms are thrown into space. Some of them form molecular hydrogen, which is later gathered by other stars to make new planets and living things. Others remain alone and lost forever in the vast emptiness of space. So let's recap what would happen to your body if you fell into a burning star. First, You would be burnt alive and your body would disintegrate from the extreme heat. Then you would be crushed by the star's gravity until you became a pancake. Afterwards, your body would be spun around by the magnetic fields until you were torn to shreds. Next, you would be vaporized, and your atoms would either form new elements or float off into space alone and forever. I think it's safe to say that if you ever plan on visiting a B-type star, then you should keep a safe distance. If you came too close, then you would be in for a world of pain. So do us a favor and stay far away. What would you do if you found yourself falling into a burning star? Would you try to protect yourself, or would you accept your fate and enjoy the ride? Let us know your thoughts in the comments below. Also, there are many other dangerous places in space. For example, you may have heard of the Great Filter, a hypothetical barrier that prevents civilizations from becoming like us or further. To learn more, check out the video, Great Filter: Why Civilizations Don't Become Like Us. We hope you enjoyed this video and learned something new. If you did, please leave a like and subscribe for more videos like this. Thank you for watching, and we'll see you next time.